Hi, everyone. Thanks a lot for coming. So we're going to talk about defibrillating web security. In particular, I'm going to try to persuade you that current technologies that we have for web security are inadequate and are an artifact of very kind of old mentality that we inherited from the 90s, right? So before we proceed, we'll talk a little bit about the current state and what's the current state of technology and the industry is. And if you look at it, you will see that right now, a lot of vulnerabilities, if you look at all of the vulnerabilities that we have, a lot of the vulnerabilities will boil down to what? To the fact that there is no way for you to tell whether certain input is actually originating from a trusted source or non-trusted source, right? So every single vulnerability in web applications we have, or majority of them, can be reduced to that, right? If we look at SQL injections, it's the fact that we're using an untrusted string as a part of trusted SQL query, escaping it before that. If we're talking about XSS, is we're displaying untrusted input on the page without, again, doing anything to it. So it all boils down to the fact that we are unable to tell where the data is coming from, right? And one of the reasons and primary reasons for that fact is because we are still using strings to represent everything, right? If you look at the web application now, if you look at basically any web application, if you are looking at the HTTP request, all of the HTTP APIs, everything is based around strings. Strings are everywhere, right? And have you ever wondered, why do we have strings? Why are we using strings to represent everything, from HTTP headers to HTTP parameters to every other form of input? And that's a very interesting question, right? Because we have actually languages typed, for example, Java, yet we still use strings to represent. And then you have to, again, remember which requests need XSRF protection, which requests do not need XSRF protection. And again, manually, you have to keep all of that in your head and remember to do the right thing. And authorization is another very good example of that, right? And that's probably where the most devastating vulnerabilities come from, right? Still up to date, let's imagine you have some sort of service, right? And say your service allows you to retrieve something from some sort of storage, right? And what usually the way you do it is by using a globally unique ID, right? If it's a database table, you'll have an ID of that particular row in the table, right? So your APIs usually are designed around this global ID, right? So when you retrieve something from the database or you retrieve something from anywhere, your API will say, for example, get user data, and then the parameter to that will be user ID, right? And so when you do that, when you use globally unique IDs and your APIs are based around that, you need to make sure you actually carry out authorization checks before you actually do that, right? So you will have to go, and before you issue that particular call, you have to make sure whether that user has access to that particular object, and you need to make sure that a user is authenticated. And there's all those things that you have to do before you can carry that out, right? But whereas the right way to design authorization API and build authorization into your application to make sure that whenever a new developer comes and joins your product who does not have all these maps in his head of where which parameter comes from, what are the assumptions at any given stage, to make sure that that doesn't happen, the correct way to design such API would not be designing it around just the globally unique ID, but maybe with bypassing also authentication credentials along with it, right? And once you pass authentication credentials with your API to retrieve data, you could have those kind of authorization checks centralized. But in reality, a lot of developers will, when they see that, they'll be like, oh, that's extremely inefficient, et cetera, et cetera. So technology is very, very much manual, and a lot of things we have to do are very manual. And so having said that, there are a lot of things that people still tend to automate, right? For example, if you're a developer and someone was hired to do a web security review of your application, and they discovered 10 XSS vulnerabilities in your application, right? After fixing about 6 or 7, you'll start thinking, well, wait a minute, can I generalize this? Can I make sure that I don't actually have to do it for every single variable interpolation. Can I somehow make it generic? And then the first idea you get is to, well, what I'm going to do is I'm going to HTML escape everything, right? So, and that's what usually happens, right? If you look at Rails, I think if you look at Django and a lot of other, there are some Java template systems, there is a way for you to go ahead and enable a feature which will HTML escape everything, right? And when you HTML escape everything, there are a lot of interesting issues that arise that I'm going to talk about. But the general typical advice that we give to people is escape everything. And you can do it manually or automatically. When you do it automatically, it seems like it's a really good way to do that, to HTML everything. But there are a lot of problems. Let's, for example, look at this particular code. So first of all, I want to say that probably people with Irish last names single-handedly discovered more SQL injections and cross-site scripting bugs than probably any security consultant individually in the past. But if you look at this particular piece of code, what do we have, right? So let's say we have a templating system that says where we, in a JavaScript context, we assign a value to a variable foo, right? And it's taken from the variable called lname in your templating system, right? And you have an Irish person registering to use your website, and once they registered for that, what do you see? You see that there is a single quote, and you are using single quotes to quote your variables, right? So can someone tell me what will be the right way to escape it? Do you put a backslash in front of the single quote, or do you HTML escape everything using ampersand #39? Any ideas? What would be the right way? No? Well, so the right way would be to put a backslash, right? Because, and I will show you why it's the right way. Unfortunately, in order for you to be able to put the backslash in there, you need to actually know what is the context in which you are evaluating this particular template. In this particular case, the context is JavaScript. But in addition to that, another piece of information here is that you are inside of the variable assignment, which is quoted by a single quote, right? So if you are applying an automated HTML escaping, in this particular case, the way you're going to escape is using the second example. Your output is going to look var foo equals 0 ampersand #39 kernel. And when that happens, a lot of it kicks off a really interesting chain of events, right? And another typical, and the chain of events is as follows. This will demonstrate that. What happens is that one of the advice that you usually give when you have people developing web applications, right? You say, hey, try to avoid using inner HTML. Is that correct? Do we tell people not to use inner HTML when they write JavaScript applications? Yes, we do, right? I hope. And when we do say, the reason why we say that is because when you assign to inner HTML and parts of it are user-controlled, what will happen is obviously you're going to have an XSS. Bear with me, this is not an XSS talk. I'm just using this as an example, right? So let's say we tell them, do not use inner HTML, it's dangerous, use inner text if you can. In this particular example, let's say we want to assign the value of the variable name to a value of this div, right? So we do get element by ID div once we retrieve this div. If we're going to assign to inner text, the way it will appear on the page is actually going to be HTML escaped into HTML entities. So it will look like O ampersand #39 kernel. And that's how it's going to look on the page. So when the developer will first follow our advice and say, OK, I'm not going to use HTML, I'll use inner text. Everything is going to work fine until an Irish person registers on the website, right? And when they do, they're going to start complaining about, well, what the hell? Why is my name looking funny here? Why is my name looking like ampersand? Please fix, right? And the developers, once they start investigating that, they will see, oh, wait, so we HTML escape this, and then when we assign it to inner text, HTML entities do not get evaluated. So the solution they will come up with is that, oh, wait, if I assign it to inner HTML, in this particular case, then it actually works and it displays correctly. And when that happens, obviously, we get an XSS vulnerability. Interestingly, I don't know if you've ever noticed, when you surf on the websites, a lot of times you see that sometimes you see HTML entities like this in the text where they shouldn't be. But at other times, you actually see backslashes in front of interesting characters like single quotes and double quotes when they display to you, which shouldn't happen, right? And usually from that, you can tell kind of the evolution of this application, right? If you see HTML entities like this, what that means is that someone did a security assessment of this application and owned them via XSS, right? Found a bunch of XSS bugs, and people were like, okay, let's just HTML escape everything. If you see backslashes, that usually means that the application got owned previously using a SQL injection, most likely, right? Because once you get owned using SQL injection, if it's a PHP app, the first thing you're going to do is enable GPC magic quotes and stuff like that, right? So you will escape everything. And when you do that, you will have those artifacts of backslash where it shouldn't be. And that's usually how you can tell. Now, once we move even further, right? Let's say you assign that variable, and then you want your application is growing, and then you decided to add a dynamically generated HTML form to it, right? So you want to dynamically create a form. When a person clicks edit, you're going to create a form, create text fields, and assign values to it. If you look at this code, so we have a form, we have an input field with an ID name. What we do is we get document.getElementID name, and the way you assign the value is you assign it to .value attribute. And when you assign to .value attribute the value of foo, guess how it's going to be shown? I have a little hint over there. It's going to be shown again, incorrectly escaped. It's going to have incorrect HTML entities that are not actually evaluated in this particular case. And then you see that the way you get rid of HTML entities from the input, and by get rid, I mean unescape it, is actually very, very difficult. If you look at it, if you look for solutions to that problem, the only portable problem to that, the solution to that problem, is to actually create a div and then assign to inner HTML of that div, and then read inner text from it. And this way you can unescape HTML entities. Actually, the minute you do that, you have a cross-site scripting vulnerability. Now, so that hopefully demonstrates that HTML escaping, applying this very, very simple and primitive HTML escaping to any sort of serious app is actually not going to work. And interestingly, single quote in general is a very, very, very interesting character. Recently, Rails had an XSS vulnerability where single quote was not escaped by the HTML escape function. And then if you start digging around and looking at the APIs, for example, Python has a CGI HTML escape function. And if you look at that, you will see that it actually does not escape single quote by default too. In order for CGI escape function to escape a single quote, you will actually have to supply an additional parameter saying, hey, you need to escape single quote too. So when Python did that, Ruby came along, and obviously people in Ruby probably had no clue about Web 2, and they were like, hey, so Python doesn't escape single quote, we shouldn't escape single quote too. And then it kind of got propagated, and no one actually knows why single quotes are not escaped by default. And my theory is, again, is probably because back in the day when web apps were very primitive and things, and Irish people were registering on the websites, they saw their name being funny, and they're like, hey, what the hell, fix this. And we actually got rid of escaping single quote. That's my theory. If you know why it's the case, please do let me know. Now, to escape things correctly, you have to do it contextually. And when you do it contextually, what that means is that you will escape things differently if it's a JavaScript, if it's a CSS, if it's an HTML attribute, if it's basically whatever the context is on the page. And the problem has actually been solved, right? There is contextual escaping. It was actually, as far as I know, Google were the first ones to open source a contextual stream parser which would escape in certain templates that are used internally by us, which will open source in turn to escape everything contextually and correctly. So that when you have a variable assignment with single quotes, it will actually properly escape a single quote using a special notation that they use in JavaScript. And if you, for example, if you're using Rails, if you're writing a Rails app, right, in this particular case, you can use a contextual gem. It requires, however, that you have running Java and JRuby. But if you run in JRuby to run your Rails app, then that will kind of help you. So this is the code. And say, for example, this particular Java HTML contextual escaper can be used and plugged into things like JSP, right, and used there. But again, tech is very manual and very difficult. Other examples of awkward security solutions are, again, authorization, where you have to do a lot of things manually, and it's really a pain in the ass, because every time you will run into problems of people forgetting to check the authorization. XSRF token handling. I don't know how most of you guys do XSRF protection, but if you want to have XSRF protection, which is actually robust and will survive certain browser bugs, what you will have to do is you will have to have some sort of cryptographic tokens if you want to do it statelessly. And those tokens will have to be handled, and they would have to expire at some point. And the problem with XSRF a lot of the times is that what you will have is that you will have a person opening a form in one tab, then opening one more tab, browsing there. While they're there, they will log in and relogging, and the session will change, and this token is tied to a session. Then they go back to the other tab. They start typing the super long document. They click submit, but the token has expired or the session has changed. And you throw them an exception saying, hey, sorry, your token has expired. And this is again, very awkward, because your code has to handle all of those things. It has to check, oh, there's a token expired, is the token still valid? And if not, we should get another one. And then assumptions verification. This is something that not many applications are actually doing. For example, when you write your app, and if you, let's say it's a Java app, Java web app, and then you have authentication, right? Usually the way you implement authentication is using a servlet filter, for example, right? So you have this filter on top that makes sure that user has a valid cookie and user is authenticated, right? The problem is that there are a lot of assumptions that will go on in the servlet code, right? And when you have servlet code, assuming that, for example, oh, at this stage, user has to be authenticated. The problem starts when you start refactoring your app, right? And you move the order of filters, and you move a lot of things, and basically you end up removing potentially that login check and moving it elsewhere, exposing one or two servlets whose assumptions are no longer true, right? So a lot of times in applications, if you want to have a little bit of a defense in depth, what you usually do is you would have some sort of precondition style or assert style checks in the servlet, right? Saying, at this point, I assume that user is authenticated. I assume that user belongs to this group. I assume this. And right now, there is no easy way for you to do that. Right now, if you wanted to do that, you will have to write a lot of code, and it will get really ugly, because you would have to say, oh, these I have to use it. If you know your tech, then you could potentially do it really nicely with Java annotations, but that will require some advanced techniques, and I'm going to talk about some of them now. Yeah, so these are, hopefully at this point you agree that a lot of our security technology is very, very awkward and very manual and very primitive in terms of the way it's used. Now, security industry, let's hope this works. How many of you have recently gave recommendation on addressing vulnerabilities in applications in the past, say, 6 months? Can you raise your hand? Sweet, 1, 2, only 4, really? 5, okay, yeah, okay. Let's change the question. How many of you have actually written an application ever in your life that was used by more than 100 people? Okay, so it's different set of hands with very, very little intersection, which kind of demonstrates my next point, right? What we have here is we have people, on one side, software engineers, right? We have this camp of people who are actually very interested in writing software, launching new features, iterating, shipping products, and doing a lot of those interesting things. And security to them is just another thing to do, right? They have to do UI design, they have to look at the database schema, they have to look at the API, all those things, and they have to make it secure, right? So security is just another thing for them. And they may not necessarily have the same mentality as the other camp, where we have security researchers, a lot of very smart and brilliant people who are working on trying to find new ways to exploit new vulnerabilities, find new ways to bypass mitigation, protection, etc. And these are very clever people too. And they spend a lot of time looking at reverse engineering code, looking at apps, at behavior, and coming up with all these cool new attacks. The problem is that, and one of the reasons why a lot of this technology is very kind of primitive and manual, is because the intersection of these two groups is very, very tiny. It's very, very small. Very seldomly you hear about companies having actually a security engineering department, right? I'm sure a lot of companies these days already have a security team, and security team is usually responsible for penetration tests, source code reviews, etc. But very few companies actually have security engineers, which is people who have the mindset of a security researcher, people who actually know and understand that, oh, if you have a one subtle bug, one small bug, very low impact, but then if you have 10 of those low impact bugs, you can actually chain them and make it so that you can create one critical bug out of all of those 10 tiny bugs, right? And we have this kind of creative way of thinking about applications and assumptions and breaking them, right? So, and if we get these people, but also get people who also write software, know how to write good software, because let's be honest, right? Security researchers, when they write code, they're really terrible at writing code, right? Especially writing reusable and nice-looking code, right? I mean, I'm pretty sure all of us have written fuzzers, et cetera, but once you start looking at someone else's security code, I don't know, like how many of you looked at Nmap, for example, right? It's pretty scary. But anyway, when you look at the code, any sort of code, you will see that security people do not know how to write code, right? We spend a lot of time making sure that code is secure and there's a lot of checks, but from the design perspective, from usability, it's not a very nice piece of code. So we need that intersection of security engineering to grow, and which will hopefully help us to difficult problems like static analysis, right? And so it's interesting to see that we are trying to kind of provide remedies for all of the symptoms, but there is very, very few people who are actually working on actually fixing the technology, right? And I can see that if you are breaking stuff, right? If you're a security researcher and you like breaking stuff and finding bugs, I can see that it's exciting. I can see how it's a little bit romantic that you're a hacker and you're breaking stuff. It's cool. But if you're a security company that tries to fix problems, right, by doing static analysis of web application firewalls, et cetera, then it's kind of funny that you don't want to fix the tech, but you want to provide those kind of patchy security solutions. And one of the reasons, maybe one of the explanations for this is the mindset that we have, right? Right now, for example, if I told you now, hey guys, let's assume all of you have your apps in Java, right? If I told you, hey guys, I have this awesome security solution. It solves SQL injection, right? It solves SQL injections, and it solves cross-site scripting too. First question you're going to ask me, is it going to work on my app that someone wrote long time ago, probably interns, right? They wrote long time ago, and is it going to work on my app? So there is this mentality that any new security technology or security solution that we come up with has to work on this broken old app, right? And then another thing that very interesting is, will it work on my outsourced app, right? If you're outsourcing your primary app, I mean, to do a little bit of a meme here, right? If you're having your outsourced app problems, I feel bad for you, son. I got 99 problems, but your app ain't one, right? If you're outsourcing your primary app, then you're already in trouble, right? So this mentality of, oh, will it work on the app, my internal, is wrong. We should change it, right? And because what happens now is we have the potentially cool technology that is actually not getting no one is actually using it, because everyone keeps dissing on it and saying, oh, well, it doesn't work on existing apps, it requires code changes, la, la, la. And it kind of holds because people still create new apps, right? People do. We don't only have all those legacy apps. We have new applications being created every day, right? I'm sure you have written new apps, hopefully. And when these new apps are created, because of that, we keep having those apps keep using old technologies that are broken, and then we're kind of stuck in this loop, right? And another thing which is kind of interesting, again, my theory, you may not necessarily agree, is a lot of recommendations and advice is based on this kind of like 90s mentality, where what we do is we say, back in the day, in the 90s, when you were doing security, you would most likely work in C and C++ code, and you would be looking for memory management vulnerabilities, right? And when you look for memory management vulnerabilities, there are a lot of very subtle issues, right? There are integer overflows, and you have to check when you check at the boundaries of your buffers to make sure you don't go over, right? And back in the day, it was fine to say, hey, you know what? Every time you do an arithmetic operation, I want you to actually check for integer overflows, right? And I don't know if you've seen code that does integer overflow protection, right? If you look at the code that does more or less complex operation, not just adding two things, but say it adds two things and multiplies or something, it's going to turn into a really long if statement with a lot of conditions where people will -1 from the others, make sure that it's less than this, multiply, divide, and then compare values. The code becomes really, really unreadable once you do that. So back in the day, it was okay to do that, right? However, luckily now, the technology that we have, that we're writing our web applications in, hopefully nobody's writing your web applications in C these days, right? If you're doing that, that's super cool. But the tech we have now, say Java, we have whatever, Ruby, all of those popular technologies, most of you are probably writing apps in Java, right? I'm guessing, yeah? Is that correct? Yeah? How many of you have Java apps? Yeah, 2, 3, no. How many of you have Ruby apps? How many of you don't have any apps? Okay, so someone is lying. Okay, sweet. All right, so the idea is that technology now is actually very, very advanced, and it provides us with a lot of ways to actually make all of those things a lot easier. But the problem is that because of this, because security industry has evolved from kind of 90s, right, where it was okay to be like, yeah, well, you have to check it every time. And then we kind of went along, and the mentality has not changed, right? So one of the things that I want to talk about a little bit deeper and introduce you one of the ways to use current technology in Java to actually do something cool is this. Right? Strings are everywhere, right? Strings are everywhere, as I said earlier. All of your APIs, if you look at any API to read untrusted data, is going to return a string to you, right? And my guess why we have strings everywhere is, again, it's yet another artifact of C, right? Where back in the day when you used to write apps, all you had struts and character buffers, right? And when you have a character buffer, you read character buffer, then you cast it to a struct, and then you do your magic, but it was all character buffers. And then the thing is that once we started moving to web apps, the same people said, oh, wait, so we have character buffers, but now we have strings. They translate directly and kind of translated them directly, and now we have strings everywhere. And there is no reason why we need to use strings, right? Because real languages have types. So if you look at Java, there are types in Java, right? And it's a type-safe language. So what does it mean? That means that instead of returning, when you do get parameter, instead of returning string, you could have it return what? A HTTP parameter type, right? Nothing stops us from doing that. We could have that. And then we could have a whole type hierarchy where there will be interfaces, et cetera, which will provide you with different ways to do things, but there is no reason why we need to stick to strings, right? Obviously, there are really good advantages of that. You get the type safety. So when you are showing something on the page, if you're displaying something, you can actually, based on the type, say whether you need to escape it or not. The information that this particular piece of data is untrusted travels with this variable in the type, right? You can also associate metadata with it. You can do a lot of interesting things, whether this particular object has been validated or has been authenticated, et cetera, et cetera. You can do a lot of cool stuff. The problem, obviously, because we have this pile of legacy code now, if you do that, it's going to throw in a security error too. So it's going to say, hey, this is actually an insecure operation because this particular data is tainted. And it's cool in this particular case because you see how taint is actually propagated onto the string where tainted string is interpolated in, right? So /tmp/godkumis, the final string will be tainted too because they propagate the taint. So it's very awesome, right? And there are a couple of things that you need to know about tainting, right? So in tainting, there are three main things. Well, taint source, so the source of tainted data. Usually it will be an HTTP parameter or something like this. Then there is a taint sink. A sink usually is what would be a security-sensitive function. It could be a SQL query, it could be a file operation, it could be eval, it could be anything that's sensitive. And another very important thing is that you want taint to be propagated. Because remember, if you do a dynamic SQL query in Ruby, for example, you will write select all from this and this, where foo equals, and then you will use string interpolation in there, right? So you want to make sure that taint is propagated onto the resulting string and is seen correctly. And there are a couple of interesting cases, right? You can concatenate and add strings like here, like we see there, clean plus tainted. Foo should be tainted. If you clean with tainted, in this particular case, the resulted string should be tainted. And then in Ruby, there are certain other functions like, say, tainted.gsub, which lets you substitute things. In this particular case, the resulting string should be tainted too. There is a way for you to mark string as untainted by just calling .untainted. Yeah? So that's how taint propagation is very, very important. So you may wonder, if this system is so awesome, why is no one using it? Any ideas? Because it's pretty awesome, right? If you have a Ruby app, and you enable safe levels, and you mark your HTTP parameters as secure, and then you modify your SQL code to never do untainted data, to never use untainted tainted data, then you should be fine. You will not have any SQL injection bugs in your code. Why is nobody using it? Well, I actually pointed out why, yeah. Why? The reason why is because it's inflexible. A, it's inflexible, and B, it's binary. And we'll talk about each in a little more detail. So why is it inflexible? Like I showed you an example. For example, you have eval foo, and then it will throw you a security error. That means that eval function actually has a code that says if tainted, throw a security error, right? So does file operation methods. So do other security-related things like, say, send and et cetera. So there are a bunch of standard methods that actually check the taint. The problem is that a lot of times the tainting system is also used by a larger security system. For example, if you look at Ruby and you look up Ruby safe levels, you will, once you go to the fourth level or last level, it's crazy. What they're doing is they're effectively trying to create a sandbox for untrusted code, right? Now, what they're doing is they're trying to may be able to come up with more rules for it and use it more widely. And we need to make it contextual, as I demonstrated, because it's binary. Because of the binariness, there are a lot of ways for you to actually bypass that system. So practical, again, we need to keep in mind that majority of apps do not run untrusted code. They are client-server apps. And we need to try to solve the problems that applications actually have. Again, not try to sandbox things. Configurable. Let me choose sources of untrusted data and sinks, right? I want to be able to say, hey, for now, I only care about, say, eval, and I only care about file operations. And the way I read my data is from this particular method. Do the rest for me, right? And then you need to also be able to configure untainting. So you can specify and say, hey, I want to make sure that if this particular code, this particular tainted string goes into this particular method, I want it to be marked as safe for this particular context, and it will become more clearer. So introducing Gravitsapa. Gravitsapa is a cool name from a movie called Kin Dza Dza. It's a Soviet movie. It's really cool. You should check it out. It's science fiction. So Gravitsapa is a runtime contextual taint tracking systems. We've implemented the prototypes in Java and Ruby, which are very, very different languages. And it has really cool features. So it's contextual, right? Meaning that once you have a tainted string, it forever remains tainted. It's tainted forever. And the way it becomes safe, it only becomes safe for certain context. So you can save that. So once you have a tainted string, if you HTML escape tainted string, it becomes safe for HTML context. If you validate the path of that variable, it becomes safe for a file path context. So there are those different contexts, and those contexts are traveling with the data. And then It's configurable. There is a configuration file that effectively lets you specify, and I'll show you an example later. It will effectively let you say, oh, okay, this is my taint source, this is my taint sink, this is my cleaner. And then the coolest thing, it doesn't require any changes in the application at all, right? Which is based on our current broken assumptions about how security solutions should work. This is awesome, right? So Java version. Java uses a thing called class file transformer. It's actually a really, really amazing feature, which is heavily, heavily underused in the security, in the application security area. It was introduced in Java 5. What it allows you to do is it allows you to instrument classes. Means it lets you modify the code of any or every single class in the JVM, including classes that have been loaded. And previously, before Java 5, if you ever wanted to do something like this, you have to mess around with class loaders. You have to create your own class loader. Then your class loader will go and load this class and modify it before doing it. You don't need to do that now. Now you have to just specify one command line argument to Java with your jar, and the bytecode is going to be sent to you for instrumentation, and you can modify it, effectively adding anything. You can even modify JDK classes, right? GRE classes. So whatever the Sun's classes, you can actually go and modify them. I just called Oracle Sun anyway. It was implemented by George Depress. He was an intern at Google. Now, one of the things that you will probably know and probably ask and have a question about, so in order for you to have a system like this and for it to work, you need to modify string object, right? String class, in fact. And there are several ways to do that. First of all, in Java, strings are immutable. Means once you create a Java string, you can never modify it. The only way for you to modify anything in that string is to create another string. Yeah? And if you start looking online for some examples on how to modify Java, and you can even find some papers about Java taint tracking online, they will tell you, oh, our solution only works with this particular JVM implementation from whatever, IBM. Because it crashes, it actually segfault on Oracle's JVM. And the reason for that is because we are using strings everywhere, Sun actually added a bunch of optimizations into the JVM about the string class and about the assumptions. It actually has assumptions about the offset of certain fields natively, so it can quickly jump there. Because we use strings so much, they actually optimized, and they actually did a lot of cool things with that. So, but if you start modifying the class file itself, using basically by modifying it in the code, you will get in trouble. It will basically crash. Java 5 agents solve the problem. The way it works is basically you write your class file transformer. It will give you effectively a byte array with the bytecode of the class. And then there is really good documentation online. It allows you to modify classes that are being loaded, but also classes that were loaded before your agent too. Because once Java starts, string class would have probably already been loaded, but you can still instrument it later on, very early in the process. The only limitation of this is that you cannot add new fields. And that's an interesting limitation, right? That you cannot add new fields, or you cannot add new methods, or you cannot change. Say, if someone declares something final, you cannot modify that. And we used OW2's ASM bytecode modification library. It's a cool library that allows you to easier instrument bytecode. Everyone is using that, and there are libraries built on top of that. Right? Remember, strings are immutable, and instrumentation does not let you add anything, any new fields to any class. You cannot do that. All you can do is effectively modify the code of methods. Where would we store taint data? If we look at the string class, we looked at everything is final. The string class itself is final. What that means is that you cannot create a subclass of string. Again, my guess is this has been done to be able to implement optimizations, right, for strings. It has a character array, which stores the string itself. And it has two interesting variables, offset and count. Again, as you can see, all of those variables are final. So once they are assigned, you cannot do anything about it. So the way it happens, if we have a string that says Kumis is the best drink ever, and we create new Java string, the way internally it's going to be represented is offset is going to be 0, and the count is going to be 27, basically the length of the string. And the cool thing that they do is that when you call a substring on a string like this, what they will do, if you call substring of 7, they're going to create new Java string, but it will use the same character array. And the only thing it will adjust in the new string that it will return is the offset and count. So the minute you do a substring on foo, it's going to use the same backing character array because it's immutable, because you cannot change it. They can do that. They do that, they adjust offset and length, and then you have a new view of the string. You don't actually have a new string, but you have a view of the string, right? So once we have that, where would we store taint data? Well, after considering a bunch of solutions, someone proposed that we do this. What we do is we essentially take the beginning of that character array, and we hijack the first, whatever, n bytes of it to store our tainting data. And the way we can get away with it by doing a simple trick, just like they do with substrings. What we do is we adjust the offset and adjust the count. Well, count in this particular case is actually incorrect. It should be 27. But the idea is that originally it was one long string with our tainted data stored in line. But when we called substring on it, kind of like a substring, we've moved the pointer, and then no one can actually see that data. Well, the strings cannot see the data. So our changes are actually invisible to the app. But we can still try to get access to it. In our case, we use reflection to store a field of value and get access to it whenever we need to. Reflection is actually kind of slow, but in latest Java 7, they introduced a couple of new things, so we're going to plan experimenting with that. What does a taint marker contain? It contains a taint marker, basically some sort of marker saying that, oh, this is our taint marker. And it stores contextual safety bits. So you have the safety bits that say, yeah, this is safe for SQL, this is safe for HTML, this is safe for this. And then we have, what we do is, once you configure your sources and sinks, we effectively modify your code to look like this. For example, if you have a getParameter method in your HTTP request object, which returns the string param value, what we add dynamically, we dynamically modify that method to do return taint.markAs tainted and that particular string. What that does is it modifies it, marks it as tainted, and returns it. And the change is absolutely transparent to the caller. And now, when we have a sink, for example, a file class, we instrument the file class. In this particular case, it will be the constructor. And we say, check taint. We pass the argument, and then we pass the context for which it has to be safe. So it's going to go and look at safety bits and going to be, OK, pass. Does it have a file pass safety bit set? And if it does, it will allow the operation through. Otherwise, it's going to throw a security exception. You can configure it. And then the Taint Cleaner. A lot of times when you talk about taint tracking systems, one of the problems that people every time bring up, they say, oh, but how are you going to deal with character by character comparison, right? For example, when you do HTML escape on a string, what you essentially have to do, you have to loop over every single character and create a new string from that. The answer to that is actually very simple. We don't care about this. We do not track character by character basis. What we do is we look at your HTML escape function and simply hijack the return call to whenever you return the resulting string, the new string, we're going to mark it as safe for HTML, like here. So we say taint safe for HTML and then return value to string. So this way, we only care about the strings and not actual characters. And then the taint propagation, right? Obviously, you will want to have ability to say, if you have a dynamic SQL query, what usually happens is that people concatenate values, right? Like, say, commits is the best using pluses, right? Luckily, in Java being so awesome, and you will know why I said that, is because luckily in Java, it converts to string builder. When Java compiles your string concatenation code, what it does under the hood, and the way Java bytecode looks like, is like this. It's going to do new string builder, dot append, dot append, dot append, and toString. So that means is that all we have to do is we have to instrument string builder class to propagate the taint, which is what we did. And the rest is pretty straightforward. And this is configuration, which I think you will find interesting. So first of all, we have this. We specify taint source. So we say, hey, I know the format looks a little bit ugly. if you're not used to Java internal representations, but that can be made easy very easily, right? But the idea here is to say HTTP servlet request implementation, get parameter with string argument and string return value. They return, that's a taint source, right? So that's the source of our taint. Then we say sanitizer, sanitize path with mod type is modification type will be taint set safety, which means mark it safe for. And in this particular case, we specify safety tag as file path. And then here, it says, OK, if you do file reader and the constructor takes the string, parameter number 1 has to be marked as safe for file path. And you see how you don't have to deal with bits. It does the bits for you automatically. So that's I think, pretty sweet. Now, bytecode with ASM is obviously easier than Java code, because when you look at Java code, you say, oh, well, how do you do that? How do you do? In bytecode, it's very easy, because in the end, there is a return call that returns where return value is on the stack, so we can just take it and muck with it. It's a very, very extremely powerful facility. You can use this to implement authorization check, XSRF token check. Basically, all of the things I was talking about being awkward earlier, you can use bytecode instrumentation to pretty much apply security checks across your application, right? You can sandbox apps using that. And the Ruby version of it is interesting, right? So Ruby, I don't know if you know Ruby, but in Ruby, strings are mutable, which makes taint propagation a little bit difficult. The rules become more complex, because once you write, if you have a safe string, but you write tainted data into it, the whole thing becomes untainted, etc. What we did is we monkey patched string object and added methods to do it. Because in Ruby, it's very easy. Everyone is doing that. Everyone's monkey patching stuff like all day long. So we did that too. The problem with Ruby monkey patching was that, hey, in Ruby, theoretically, they say that, hey, in Ruby, you can monkey patch anything. Anything you want will work, because we're a dynamic language. We want to let you do whatever you want, right? Well, that's a bit of a BS, because first, you cannot monkey patch gsub exclamation mark. And the reason for that is if you use a regular expression in gsub and you use capturing groups, like such as $1, for whatever reason, they are bound to different contexts, and the caller will not see them. So basically, the minute you patch gsub, do something and call original gsub, if the caller uses capturing groups, they're going to be empty, which is really annoying, right? And it's a known bug in Ruby. And another thing, you would think that they will let you monkey patch string interpolation, but they don't. So there's no way for you to monkey patch or patch string interpolation anyway. To address this, I had to patch JRuby, which is what I used for this. And very simple. It just calls our method if one exists before that. The Ruby code was primarily aimed at demonstrating the concept. The idea was to see if the concept is really working and it's really cool, and potentially pitching it for Ruby too. So if you have any sort of connections with Mats or anyone in Ruby 2 community, let me know. It would be really interesting to chat with them about this to see if they're interested in doing something like this. Obviously, the system needs a little bit more testing. Java version will eventually be open sourced after it's been tested. Obviously, the first question people will have is performance. What's the performance impact? This is still being kind of evaluated. With first Java version, we wanted to make sure it actually works and it doesn't break apps, like complex, big applications. And it didn't, so that's good. But yeah, more to come. And that's it. If you guys have any questions, I'll be more than happy to answer them. I think I did really well on time, actually. No questions at all? No?
Nobody has a question for Meter?
Sweet. Yeah, well, thanks a lot. And yeah, see you around.
Thank you very much, Meter.